Alright guys, so I'm out today. Let's talk about this IXL assignment. So we're going to go to Learning. We're going to go to 7th grade, which is right there. And then we're looking at F.5, F.6, F.7. So here is F5, least common denominator. We've done this before. This should be pretty much a review. So least common denominator of 9 and 3, right? So we're looking only at the denominators. We're asking ourselves, what is the LCM of 9 and 3? Well, 9 times 1 is 9. 3 times 3 is 9. So the LCM there is 9. LCM is the exact same thing as the LCD, but we're looking only at the denominators, right? So basically when we say LCD, we're talking about the LCM of the denominators only. That's the same process. What's the least common denominator of 5 and 10? Okay, so we're looking at 5 and 10. We're trying to find the LCM there. 5 times 2 is 10, so there you go, it's 10. 10 times 1 is 10, 5 times 2 is 10. 8 and 4, 4 multiplied by 2 is 8, so 8 is the LCD. Wait until we get to some tougher ones here. 12 and 6, the LCD between 12 and 6 is going to be 12, right? 6 times 2 is 12. 12 times 1 is 12. All right, 3 and 12. I'm sorry, not 3 and 12. 4 and 12. 4 and 12. 4 times 3 is 12. 12 times 1 is 12. So 12 is the LCD there. 6 and 12. Okay, well 6 times 2 is 12. 12 times 1 is 12. 12 is our LCD. 10 and 5. 5 multiplied by 2 is 10. 10 multiplied by 1 is 10. There you go. All right, here we go. Finally, 11 and 6. These have no common factors. So they call these relatively prime. Numbers with no common factors are relatively prime. So just multiply them together. 11 times 6 is 66. So 66 is your LCD there. 10 and 4. These do have common factors. So there's a couple ways you can do this. You could write out the prime factorization and use that method for finding the LCD. Or you could think about the multiples of 10. 10 times 1, well, that's not a multiple of 4, but 10 times 2 is 20. 20 is a multiple of 4. So if you're going to use this method, I would recommend you multiply the larger of the two numbers, the larger of the two being 10 in this case, and then think about the multiples of the smaller number. So 10 times 2 is 20. 20 is a multiple of 4. So the LCD here is 20. So that's pretty much how the first one works. Please get to 85 on that. Going back to the choices here, we're going to go to F.6. F.6. So again, get an 85 on all of these. Compare and order fractions. Okay, so which fraction is greater? This one's pretty clear. Same denominator, higher numerator, 3/7 is greater. 8/11, 9/11, again, same denominator, higher numerator, 9/11 is greater. Oh, less, excuse me. Read carefully. Which one's less? That one's less. Don't get in a hurry like me. Which fraction is less? Which fraction is greater? 1/7, 5/7, same denominator, higher numerator, 5/7 is greater. Which fraction is less? Okay, here we have different denominators, right? So let me show you how we do this. 1/8 and 1/4. 1/8 and 1/4. Let me get a new page going here. 1/8 and 1/4. 1/8 and 1/4. We need to find a common denominator. To do that, we got to find the LCD. What's the LCD of 8 and 4? We just did this. The LCD is 8. So how do we change a 4 into an 8 using multiplication? We're going to multiply by 2. 4 times 2 is 8. I need to put a 2 in the numerator. You might say, how are we allowed to multiply by 2 over 2? Well, what is 2 over 2? It's 1. Multiplying by 1 changes nothing. So 1 times 2 is 2. So we're comparing 1/8 and 2/8. And obviously 1/8 is less than 2/8. So back over here, which one's less? 1/8 is less than 2/8. Which fraction is greater? Same denominator, higher numerator, 8/11 is greater. Which fraction is less? Okay, 9/10 and 5/7. 9/10 and 5/7. 9/10 and 5/7. Okay, looking at the denominators, 10 and 7, these are relatively prime. They do not have any common factors. So we just multiply them together to find our LCD. So we're going to multiply by 7 over 7 here. 10 times 7 is 70. 70 is our LCD. Excuse me. 9 times 7, that is 63. And then over here, we're going to multiply by 10, right? Because 7 times 10, we need that common denominator is 70. We're going to multiply by 10 in the numerator. 5 times 10 is 50. So 63/70 is greater than 50/70. So 9/10 is greater than 5/7. 9/10 greater than 5/7. 9/10 is greater than 5/7. So 5/7 is less. There you go. We'll do one more. Yeah, sure. 2/7 and 9/11. 2/7 and 9/11. 2/7 and 9/11. 2/7 and 9/11. Okay, 7 and 9, they are relatively prime. So the LCD is just going to be the product of 7 and 11. So 7, we got to multiply by 11. Our LCD is 77. In the numerator, we have to also multiply by 11. 11 over 11 is 1. We're allowed to multiply by 1 and nothing changes. 2 times 11 is 22. And then here, we have to multiply by 7. 11 times 7 is 77. We should have a common denominator. We have to multiply by 7 in the numerator. 9 multiplied by 7, 63. So 22/77 is less than 63/77. So 2/7 is less than 9/11. 2/7 is less than 9/11. Which one's greater? 9/11 is greater. You get the idea. On to F.7. Try to get to 85, not try, get to 85 on all these. F.7. Compare fractions, word problems. Yesterday, half the flights at Clay County Airport were delayed. At Boone County Airport, 6/7 of the flights were delayed. Which airport had a higher fraction of delayed flights? Okay. Think about what's half of 7? What's half of 7? It's 3.5, right? 3.5 is half of 7. So if this is greater than 3.5 over 7, which it is, then there were more flights delayed at Boone County. Okay? So again, 6/7 is greater than 1/2. So Boone County Airport had a higher fraction of delayed flights. Get it together, Boone County. Recently, half of the items sold at Key Sporting Goods were baseball caps. At Johnny Sports, 2/9 of the items sold were baseball caps. Which store sold a greater fraction of baseball caps? All right, 2/9. What's half of 9? 4.5. So 4.5/9 is 1/2. So 1/2 is greater than 2/9. 1/2 is greater than 2/9. So that would be Keith. Half of the items sold at Key Sporting Goods were baseball caps. Which store sold a greater fraction of baseball caps? Keith did. Alice finished 2/3 of her to-do list items, while Gabriel completed 2/9 of her. Gabrielle completed 2/9 of her to-do list items. Who finished a greater fraction of her to-do list last month? Okay, well, this works pretty well actually if you think about like half, right? So what's half of 9? 4.5 is half of 9. What's half of 3? 1.5. So this is greater than 1/2. This is less than 1/2. So who finished a greater fraction of their to-do list? Alice. Who finished more than half? She finished 2/3. Alice finished more of her to-do list. Now let me show you how this can be done, like proving it out mathematically. And I'm going to leave you with this. So 2/3 and 2/9. We're going to find the LCD of 2/3 and 2/9. Well, what's the LCD of 3 and 9? The LCD is 9. So we're going to multiply by 3 over 3, and we get 6 over 9. This is already over 9, so 6/9 is greater than 2/9. 6/9 is greater than 2/9, which is to say 2/3 is greater than 2/9. So there you go. That was Alice, I believe. Okay. Thank you very much for your attention. Good luck on this. Well, we'll come back in a second. All right, so I'm sending the 4.9 Practice Master to everybody right now. So if you're in 7th period, you should have that right now. It's coming your way. Today we're going to talk about negative exponents. It seems like it's quite tough, but it's really not that bad. So we're going to work out a number of these together, and then I'll kind of send you off on your own to try some, and you can check back here. So if you're watching in 7th period, I'm going to pause the video, and you can try some problems on your own when I tell you to, and then you can come back here and check your answers against what I have. I'm probably not going to give you all of them, but we'll probably go through the odd ones together, and then you guys can go back and do the evens on your own. Okay, so if you're in class, please make sure you're paying attention and don't just tune me out. Also, don't try to work the evens on your own. Please be patient and wait on me. Does anybody not have this open yet? Everybody's with me here? Okay, let's talk about negative exponents. First, let me provide an example that you already know about. Let's say we have 8 to the power of 6 over 8 to the power of 3. What do we, let me actually let's do 8 to the power of 2. There we go. 8 to the power of 6 over 8 to the power of 2. What would this be? Who knows? Taylor?
It would be 8 to the power of 4.
Yeah, in the numerator or the denominator? The numerator. So we're going to go 6 minus 2, which gives you 8 to the power of 4 in the numerator, and we got a 1 down in that denominator. Let's switch the exponents now. What if the exponents were 8 to the power of 2 in the numerator and 8 to the power of 6 in the denominator? Sarah Kate, what would that be?
Wouldn't it be when you subtract in this one?
You would.
That would be 8 to the power.
8 to the power of 4, right? 6 minus 2 is 4. The larger exponent's in the denominator. So what's in the numerator now? 1, right? There's a 1 up there. There's always a 1 up there. Even when everything's gone, there's always a 1 up there. Now, instead of subtracting 6 minus 2 and dropping it down to the denominator, let's instead do 2 minus 6. So in the numerator, 8 to the power of 2 minus 6. What does that equal to? 8 to the power of what, Taylor?
Minus 4.
Yeah, negative 4. And remember earlier we said this is going to be 8 to the power of 4 in the denominator? Because it is. It's the exact same thing. So if we have 8 to the power of negative 4, that's a negative exponent, you can bring it to the other side of the fraction, either down or up, and that exponent will always change signs. It was 8 to the power of negative 4, now it's 8 to the power of positive 4. That exponent will always change signs, and we have 1 over 8 to the power of 4. So here's what you need to know. Moving your power, that'd be the base and the exponent, to the other side of the fraction, either down or up, the exponent will change signs. They are equal to each other. They are equivalent. Does that make sense? Okay. With me, Veda? So let's take a look at number 1. We're going to rewrite this using positive exponents. So who thinks they understand what this is going to be? Campbell?
I think, try to say it's positive. The answer's going to be positive.
What's it? Well, we're going to change this exponent so it's got a positive exponent. Right now it's in the numerator, right? So if we want to change that to a positive exponent, we got to bring it down to the denominator. The exponent changes signs. What is in the numerator? 1. It's 1 over 6 to the third. That's all we're doing. You'll see. If you're confused.
Wait, I'm so confused.
Yeah, okay. Okay, here we have negative 3 to the power of negative 2. The exponent is negative. Is it in the numerator or the denominator, you guys? The numerator, right? So we're going to drop it down to the denominator, keep everything the same. The only thing that changes is our exponent changes signs. What's in the numerator? 1. So it's 1 over negative 3 to the power of 2. Okay? Let's try another one. 5. Okay, be careful here. We have two different exponents. That's a to the power of negative 4. This is b to the power of what? 1. B to the power of 1, is that positive or negative? So it's going to stay right where it's at. We're not moving that b at all. A to the power of negative 4, that's a negative exponent. We're going to move it down to the other side of the fraction, to the denominator. And what happens to our exponent there, Zella?
It goes to positive.
There we go. So b to the power of 1, or you could just say b over a to the power of 4. Yes?
So why did you put b at the top though?
It was already in the numerator, right? This is over 1. So b stays in the numerator. It's got an exponent of 1, so we don't move it at all. It's already a positive exponent. We don't need to move it at all. Okay? Let's take a look at 7. You guys can do this one on your own. Try it out. Beta, what's that going to be? What's that going to be?
3 to the power of 1. 3. 1 over 3.
Yeah, 1 over 3 to the power of 1, which is just 3. So you can say 3, or you can say 3 to the power of 1. I'll take either. But because we have a negative exponent, you move to the other side of the fraction. All right? Let's take a look at... I think you guys are good on 9. Let's take a look at 11. Actually, wait. 8? All right, 8. Here we go. 8. 3 to the power of negative 3 is in the denominator, so we got to bring it up to the numerator. And it becomes 3 to the power of what, Benjamin?
3.
3. What's in the denominator?
1.
1, right? What happened to this 1? It's still there, right? 1 times 3 to the power of 3. You don't have to show it, though. So 3 to the power of 3 over 1. We're just going to write that as 3 to the power of 3. Let's take a look at 11 together. 4 to the power of what? Lucy, what is 4's exponent here? 1. What is the exponent of x? 1 as well. So because those have a positive exponent, we do not move them. They stay in the numerator. 4 times x over y to the power of negative 3. We're going to move that to the other side, to the denominator. And we get y to the power of now positive 3. So there we go. So anytime you have a negative exponent, you have to move that term to the other side of the fraction. Okay? All right. All of these, 13 on, we're going to write them as with negative exponents. This is the only time this ever comes up, so it's good practice, but it's not really needed. W to the power of 2, you bring it up, becomes w to the power of negative 2. V to the power of 1, bring it to the bottom, to the denominator, becomes v to the power of negative 1. So yeah, it's the exact same thing we were doing, but the directions say write each with negative exponents. So wherever you see a positive exponent, you got to change that side, like move it to the other side of the fraction. Let's take a look at 15. 15, that's a to the power of positive 1. We're going to bring it down to make it a to the power of negative 1. B to the power of 5. We're going to bring it up to the numerator to make it b to the power of negative 5. So there you go. So that's how that's done. I think that's pretty self-explanatory. Do your best on these. I would advise you to convert each of these so that they have positive exponents first. So for example, on 29, this would be 2b over a to the power of 3. And now sub in for a and b. So that'd be 2 times b, which is 12, over a to the power of 3. A is 2, so that's 2 to the power of 3. 2 to the power of 3 is 8. 2 times 12 is 24. 24 divided by 8 is 3. So there you go. That's how that's done. Adjust it so that all the exponents are positive, then sub in, and then simplify. All right. So there was some confusion in class about like what this actually means. 2 to the power of negative 2, we can rewrite this as 1 over 2 to the power of positive 2 now. 2 squared is 4, so that's 1/4. So 2 to the power of negative 2 is 1/4. You don't have to actually write that, but it's good to know. And there was some confusion like on number 19, because number 19, yes, negative 5 is a negative number. It's taken to the power of positive 1, though. So when we change it to the other side of the fraction, negative 5 doesn't change its sign. Negative 5 remains negative. When we move it to the other side of the fraction, the only thing that changes signs is the exponent. So number 19, 4 to the power of 2, you bring it up, you get 4 to the power of negative 2. Negative 5 to the power of positive 1, you bring it down, you get negative 5 to the power of negative 1. There you go. All right, this is not on the quiz, so please make sure you complete the worksheet. And if you have time, there'll be some bookwork for you to complete as well, but probably just end with the worksheet. Thanks, guys. Have a great day.